am going to explain the first fit memory allocation program using C. This is an operating systems lab experiment. First, we get the number and size of memory holes. Next, we get the number and size of processes. Then, we take each process one by one and check the memory holes from the beginning. We compare the process size with the hole size. If the hole size is large enough, we allocate the process to that hole and update the hole information. Finally, we display the allocation result. Header hash include stdio.h. First, this is the header file. We include stdio.h because we are using printf and scanf for input and output. Next, process structure. It means struct process. Next, we have the process structure. It stores the information about each process. Size stores the memory size recorded by the process. Flag tells whether the process is allocated or not. Hole ID stores the number of the hole allocated to the process. Hole structure. Next we have the hole structure. It stores the information about the memory holes. Size stores the current size of the hole. Actual stores the original size of the hole. Next, input section. Next, the program gets the number and the size of the memory holes. After that, it gets the number and size of the process. Allocation section. The next nested loops are used for the main allocation process. The outer loop takes each process one by one and the inner loop checks the holes from the beginning. Output section. Finally, the program displays the allocated hole for each process and the final hole status. Outer loop. For I equal to 0, I less than np, I plus plus. The outer loop takes each process one by one. For j equal to 0, j less than nh, j plus plus. The inner loop checks the holes one by one starting from the beginning. If p of I dot flag not equal to 1, this condition checks whether the process is already allocated or not. Main condition. If p of I dot size less than or equal to h of j dot size. This is the main condition. It checks whether the process size is less than or equal to the current hole size. If this condition is true, the process can be allocated to that hole. Allocation. P of I dot flag equal to 1. The flag is changed to 1, which means the process is allocated. P of I dot hole ID equal to j. Here we store the whole number where the process is allocated. H of j dot size equal to P of I dot size. Here the current value of the hole is updated. So this nested loop is the main part of the first fit program because it checks the holes and it performs the allocation. Now I will compile and execute this program using the telnet server. First, I create or open a C source file named firstfit.c and enter the program. Next, I compile the C program using the GCC compiler. The O option gives the executable file the name firstfit. Finally, I use this command to execute the compiled program. Now, I am entering the input values for the program. Here I have 5 memory holes with the sizes 100, 500, 200, 300 and 600. Then I have 4 processes with the sizes 212, 417, 112 and 426. The program will now check each process against the holes from the beginning. Allocation working. P0. First, P0 has a size of 212. H0 has only 100, so cannot fit. Next, H1 has 500, which is sufficient, so P0 is allocated to H1. Next, P1 has a size of 417. The earlier holes are not sufficient in their current values, so the program continues checking. H4 has 600, so P1 is allocated to H4. Next, P2 has a size of 112. H0 has 100, which is not enough. The current value of H1 is 212. So, P2 can be allocated to H1. Finally, P3 has a size of 426. There is no current hole that is large enough for P3. So, P3 is not allocated. Now, we can see the final output of the program. P0 is allocated to H1. P1 is allocated to H4 and P2 is allocated to H1. P3 is not allocated because there is no suitable hole available. Actual represents the original size of the hole. Available represents the current value stored by the program after the allocation updates. Thus, we have successfully implemented first fit memory allocation using C. The program takes the memory hole sizes and process sizes, performs the allocation and displays the final result. Thank you.